In this video, we're going to conduct time series tests of multifactor models and compare the results to those obtained for the CAPM. In the last video lecture, we looked at two different multifactor models. The first one was the Fama-French three-factor model. The second one was the Carhart four-factor model. We're going to test both of them. If we consider the three-factor model first, the setup for the time series test is almost identical to that for the CAPM. Theory predicts that the expected excess returns for a portfolio or stock is going to be equal to the beta on the market times by the market risk premium plus the SMB exposure times by the expected returns on the risk factor SMB plus the exposure to risk factor to the HML risk factor times by the expected returns on that risk factor. That means when we run a regression looking at our excess returns in each month, if the three-factor model holds, then the intercept, the alpha, should be equal to 0. This is a very similar test to that we used for the CAPM. The only difference here is in the implementation when we're using our linest function. Now we have three factors, not one factor. And if we think about the output from our regression now, we're going to have to think about HML, SMB, the market, and then the intercept. And for each one we're going to have the estimate and we're going to have the standard error. This is the matrix we will get in the output. Why is it in reverse order? Because when you use the linest function, Excel automatically reverses the order of the variables. We started with the intercept, then the market, then SMB, then HML. Excel reverses that ordering. So when we're looking to tell Excel where to look for the intercept, it's going to have to be row 1, column 4. For the standard error, it's going to have to be row 2, column 4. Similarly, when we look at the Carhart four-factor model, we're going to run exactly the same test, except now we've added a fourth factor, momentum. Once again, if we think about the output from linest, we're now going to have momentum, HML, SMB, the market, and then the intercept. And we're going to have estimates, and we're going to have standard errors. What are we going to have estimates for? Well, we're going to have estimates for the beta for momentum. That would be here. We're going to have estimates of the beta for HML here. We're going to have estimates for the exposure to SMB. That would be here. And finally, we're going to have estimates for the exposure to the market. We're interested only in the intercept once again, and we're interested in the standard error of the intercept. To reference those cells, we're going to be looking at row 1, column 5, and row 2, column 5. Let's go to Excel now and test these multi-factor models. Here we have the data once again for the 25 Fama-French portfolios that are based on size and book-to-market ratios. This is the same data set that we used last time. Here we have excess returns already calculated for each of the portfolios. And we have our CAPM analysis that we conducted in the last video lecture. We need to do the same thing for the Fama-French three-factor model. We need to calculate our regressions for all 25 portfolios. To do that, and to make things simpler, we're going to name a range first. Let's select all three risk factors that make up the Fama-French three-factor model. That's going to be excess returns on the market, SMB, and HML. In this case, what we're going to do is name these three factors. We'll call them 3_factors. Hit enter. And in this regression, we don't have one independent variable like we did with the CAPM. There the independent variable was just the market. Now we have three independent variables. So when we specify our regression, we have to tell Excel to look at all three variables at the same time. Now we've named the range where all those three variables are, we're ready to run our regressions. So equals, and we're going to use the index function again to tell Excel where to look once we've done the regression. Linest. Now the known Ys are going to be the small firms with low book to market. Let's select the excess returns, comma. The known X's, this is where we now have three factors and we've named them already. 3_factors, comma. Do we want to include a constant? Yes, so we just leave it blank and hit comma again. Do we want the statistics? Yes, we do, so we press 1. Close the brackets, and that's the linest function complete. Now we just need to tell the index function where to look. And if you remember, we said that to get the estimate of the alpha, we would look in row 1, column 4. We have three factors plus the intercept, and we know that Excel lists things in reverse order. So the intercept is the last column. Let's hit enter. We've now calculated the alpha. We can also calculate the standard error using a similar formula. Index linest. Select the excess returns. Select the x's, which is the three factors. Do we want a constant? Yes, so we leave it blank. We want the statistics, so we press 1, close brackets. And now we need to think about where is the standard error for the intercept. Well, that is going to be in row 2, column 4. Close brackets, hit enter. And we now have the alpha and the standard error. We can now calculate the t-statistic, which is going to be equal to the alpha divided by the standard error. Because we've named the ranges for the three factors, we can immediately copy this formula across to calculate the intercept for every single portfolio. There we go. We've now calculated the intercept for all 25 portfolios. If we scroll along, we've got to look for t-statistics that have an absolute value greater than 2. Fama and French argue that there are not very many portfolios for which the t-statistic is greater than 2 when you use their three-factor model, compared to the CAPM. And you can see the CAPM results from the last lecture above. And they're right. Well, here we have a -3 as a t-statistic. That's a bit different. But as we scroll along, when the CAPM t-statistics are high, the three-factor model t-statistics are low. There's nothing there. Look at the magnitudes of the intercepts. The intercepts were 0.45 here for the CAPM. They've been reduced to 0.15 for the three-factor model. There is some evidence of statistical significance here, but as we move along, you can see the three-factor model is explaining the returns on these portfolios well, where the CAPM was failing. So it does look like the Fama-French three-factor model does a pretty good job. It certainly improves over the CAPM. Now what about the Carhart four-factor model? If we're going to do these same tests for the four-factor model, we need to again use that trick of naming a range. Let's scroll up, and now let's select the 4 factors we're going to look at: the market, SMB, HML, and momentum. Let's go to the name box and name this range 4_factors. Hit enter. And we're now ready to run our regressions for the Carhart model. We're going to use the same type of structure as before, so equals index, open brackets, linest, open brackets. The known y's, let's select the excess returns on the small portfolio on small firms with low book to market ratios. What is the X range? The independent variables are now those 4 factors which we've named 4_factors. We do want to include a constant, so we press comma again. We do want statistics, so we type 1. Close off the brackets, that's linest finished. Now where's this output going to be? We want to look at the intercept, which is going to be in row 1, column 5, because we've got 4 factors plus the intercept. Hit enter. We now have our alpha based on the 4-factor model. Let's also calculate the standard error in exactly the same way, except we're going to tell Excel to look in row 2 rather than row 1 for the output. We just want the standard error. So row 2, column 5. Hit enter. We've calculated the standard error. We can now calculate the t-statistic, which is the alpha, the intercept, divided by the standard error. Let's select these 3 cells and copy them across. We've now run the regression for all 25 portfolios. What happens with the 4-factor model? Above, we now have the results from the CAPM, the 3-factor model, and the 4-factor model. If you look between the 4-factor model and the 3-factor model, there's very little difference for this set of portfolios. The t-statistics are similar. There's no sign of too many portfolios having significant alphas. So for this group of 25 portfolios, the momentum factor that Carhart suggested adding doesn't seem to improve the explanatory power. But maybe for other groups of portfolios it does. And that's something you're going to look at in your homeworks. You're going to look at industry portfolios, and you're going to assess whether the CAPM, the 3-factor model, or the 4-factor model is most effective at explaining the excess returns on industry portfolios. That's everything that I wanted to cover in today's video. See you in class.